Hello everyone, my name's Steve Kehoe. I'm a co-founder at BitTiger, and today I'm going to show you how to build an app store using the web framework MeteorJS. For those of you who have been following our classes, this is the third module in a set of three. We've already built a web crawler that's harvested 3,500 apps from the Huawei App Store. We've also built a recommendation engine that gives us the 5 most similar apps to each app. So today we're going to build a front end to display the results. One thing I just wanted to note before we get started, if you're not as familiar with JavaScript or web apps, there may be a lot of new information coming at you at once, particularly if you also have not used Meteor before. And that's okay. What I'm trying to do here is give you a general overview in the context of this application. You're going to be able to code a Git repository at the end and actually walk along with the code. So if you're watching this video, you could even do that first. I'm going to link that under the video so that you can clone that Git repository. And there'll also be an accompanying handout of all these slides plus some extra slides that we're not going to show in the video to give additional explanation if you're still having trouble. So without further ado, let's start going here. So the goals for today is to get an introduction to MeteorJS, to set up a dev environment for building web apps, to learn how data is passed between the server and the client, and even to the database, I should say, and to learn how we can create dynamic HTML pages to display our data. So Meteor is a web app framework that's built on top of Node.js. This means that we're going to use JavaScript code on both the client and the server. And since we're using MongoDB in this example as well, we'll even use JavaScript to interact with our database. So one of the really nice things about this as a developer is you've only got to deal with one language and you've got a full stack from all the way from the database to the client side. And we can even compile, this is beyond the scope of this video, into Android and iOS applications, which is like an added bonus for when you're doing your prototyping. Meteor also uses something called distributed data protocol to automatically synchronize data between the client and the server. So if you were making something like a chat application or Twitter or something, you can imagine, one user sends a chat message and maybe 10 people are in the conversation. Meteor is going to handle that data synchronization automatically for you, which is really useful in certain applications. The other reason Meteor is really nice for rapid prototyping is it handles many routine tasks like database interactions. We just talked about pushing data updates. So you get to work with everything right inside the Meteor code. You don't have to spend days writing logic to hook up to your database and write SQL queries and all that kind of stuff. And the other nice thing is that every time you save a file, Meteor is going to automatically recompile. And it has this feature called hot code push, which means it's going to push the changes to all active clients as well. So no refreshing your browser or anything as you're developing. This is also a really nice feature, not to be underestimated how useful that is. So let's just take a look at what, this could be called basic web app architecture, but this is really more in the Meteor context. On our back end here, we have a MongoDB. In this case, we're just going to use Meteor comes bundled with MongoDB, so it's going to run its own local copy. Later on, as you're scaling out an application, you might have your own MongoDB cluster somewhere else, and your cluster or Docker boxes running Meteor code in another place. But on the back end, basically, you have MongoDB and the Meteor server. You also have library code, which is code that's shared by both the server and the client. This could be maybe useful functions that you want on both, or in our case, it'll be something called routing information, which we'll cover in a little bit. But yeah, library code is shared between client and server. And then you have your client code, which is running normally inside the web browser or a mobile app if you compile it as a mobile app. But each copy of the client is going to have a separate copy of the client code. One of the primary responsibilities of the client code is rendering the view that the user sees, so the templates that make up the eventual HTML document in a web browser, and also handling all the user interaction. All right, so enough PowerPoint for now. Let's actually look at some real code. So, like I said before, we've already written the base application. So it was going to take too many classes to show each individual thing. about Meteor, and we are going to link to some more in-depth tutorials and keep putting out videos in the future to touch on more details. But today, again, it's just to get an overview of, what is this Meteor app and what is it all about. So let's start with the folder structure here. You'll notice these ones with the periods are hidden folders in OS X. The first one controls all of our Git repository stuff, so Git put that there. This idea folder is actually from a different, I'm using Atom Text Editor because this one's free and open source, but usually I use WebStorm for more in-depth development, and that's basically a settings folder. This Meteor folder is interesting. This is where all of the Meteor specific configuration would go. The only thing I wanted to point out here is one file called packages. These are the third-party packages that we're using. Some of these come standard, like jQuery or Session or Blaze HTML templates, which is Meteor's templating engine that we'll touch on in a few minutes. But a few of these I actually added to this package. One's called Iron Router, and that handles the routing between pages. So if you've gone to a website, you've probably noticed that you have a base URL like google.com, and then you go to /news or /images or something after the slash. That's called the route. So the router is going to, for our web application, determine which templates or which pages get served via which addresses in the URL bar. So we'll be spending a lot of time with that today. We have Twitter Bootstrap, which is a CSS framework that makes it really easy to do responsive design. Responsive design is a fancy way of saying making a website or web app that's going to work well on different size screens, from mobile all the way up to desktop monitors. And then this Barbados star rating package is actually a little third-party package that gives us the 5 rating stars that we're going to use on our app page, where you see like the average rating for an app, 0 to 5 stars. I saw a nice package for that, so figured why recode that. We're doing plenty of other coding today anyways. Okay, so that's all we need to know for the Meteor folder for right now. And let's move over to the folder structure here. So we've got 3 folders: client, lib, and server. And just to refresh here, that's exactly what I was showing here. So server code is only going to run in this block on the server side. Client code is only going to run in this block on the client side. And library code will be accessible from both the client and the server. This is really unique about Meteor, because since JavaScript runs in all 3 locations, we're actually able to do that. Whereas more traditional frameworks, say Ruby on Rails, you'd have JavaScript over here, Ruby over here, and you couldn't as easily share code between the 2 sides. So let's start looking at the server-side code to start with. The first thing you'll notice here is data.json. This is the file from our last module with all the data about the apps and their 5 most recommended apps. I just renamed it into a shorter name so it fit easier on the screen. This next one, fixtures.js. Fixtures.js, and some of this is just convention. Fixtures usually represents fixtures in your database. So I have an empty database. What's the default stuff I should load into the database? So for a lot of the time, this is maybe a default administrator user account, or as you're developing, you might load, say you're making a blog site, you might load 5 or 10 sample blog posts so you have some data to work with. In our case, what we want to do in fixtures.js is load data.json into our MongoDB so that we have the data from the first 2 modules that we can work with. So the first thing we're doing here, and we're going to look at this variable apps in a second, but this is a Meteor collection, and you query it just like you would query MongoDB. So we're doing apps.find, and we're passing an empty set of curly braces, which means give me anything in the apps collection, and then we're counting how many there are. If there's less than 1, we can be pretty safe. We have an empty, pretty sure that we have an empty apps collection. So in that case, we're going to access a package called file system, which is part of Node. So the nice thing about Meteor is it gives you a really clean API to do most routine tasks, but if you need to go under the hood, so to speak, and get to a native Node module, in this case FS is the file system module because we want to open this data.js file, it's very easy to just call npm.require and get access to that package. So let's not read too much into this package. It's not really the point of this lesson, but basically we're reading the file data.json. We are going to take the file content as one big string and then split it by new line so that we're going to have an array of strings here. Each element of the array is going to be one object that represents an app and its recommendations. And then we're going to iterate through that array, and we're going to map the raw app data that we just took out of the file to a slightly new format with different property names for our application. And then at the end, we're going to call apps.insert. Again, apps is our Meteor collection of apps, which is hooked up to our MongoDB. So by calling this, we're inserting each new app into Mongo. And that's basically it. This is only going to run once because the next time our app starts, the count is going to be greater than 0, and this won't fire again. So this is just loading our initial data the first time we run this. Okay, so now thus far we've seen we have a basic structure here. We have a client folder that's going to run on the client. We have a library that's going to be available to the client and the server. And we have a server side, which right now all it's doing is loading our data. What we don't have yet is any way to access our data on the client side. So before we get too much further, I want to introduce the notion of publications and subscriptions. So of all the data we have on the back end, some of it we want to be available to the client. In this case, we want most of our data to be available to the client because all we have is a collection of apps. But let's imagine we had a more complex web app where we had user account information and maybe other private messages that weren't public. By default, nothing is going to be published to the clients in Meteor. So we have to explicitly give permission, basically, that different parts of our MongoDB are going to be available to the client. So the first thing we're doing here, we're calling meteor.publish, which is going to set up, that's what they call these publications, something that you can subscribe to. The first one we're just going to call apps. So the first parameter of this function is the name of the publication. In this case, it's apps. And the publication is a function that's going to take a JSON object called options, and it's going to return, this is similar to the syntax we just saw on fixtures.js. It's going to call apps.find. It's going to pass empty curly braces, which means get me everything in this MongoDB collection, apps called apps. And I'm going to pass in these options. Now, we'll see what these options look like pretty soon, but basically the options allow you to do things like sort and filter and trim the results. And the reason you can use these options on the client or the server side. One of the reasons we're passing them back to the publication to run them in the server side is it's going to be more efficient to run on the server side. We have 3,500 apps. If we have to do all that work on the client side, it's going to slow down our application. So this is, you know what, let's pause for a second. One thing I meant to do earlier that I haven't done yet is actually show you what this app looks like, because I want you to see where this publication is actually going to show up in the eventual app. So let's open up a terminal. Let's actually get a new terminal. Oh, this is from yesterday. Okay, so we have a new terminal here. We're going to change to the directory that we're looking at right now, which is Documents, MeteorDev AppStore. And all you actually do to run a Meteor application is type the command Meteor. You could also type Meteor run, but if you just type Meteor, that's what it assumes you're doing. So we're going to run Meteor. It's starting its server here. That's starting proxy. It started MongoDB. And it's compiling the entire application now. Linking everything together. Okay, so look, app is running at localhost :3000. So our Meteor app is now running. We can let's just get a fresh web browser. Go look at our website. Okay, so this is our app store. We see we have a top charts page here with, I think it's about 50 applications. And if we click on any of these applications, we're going to go to a more detailed page here. I'm going to zoom out a little bit, where we can see a little bit more information about the app, the name of the developer, a little introductory description, and the customer also likes. So this is the recommended apps that we calculated in the last one, and we see that each of these links is actually active. We can navigate around, we can hit a back button to go back and forth. So the main motivation for showing you this right now, I think it just helps as you're learning something new to kind of see, okay, here's some code, here's what it's actually producing. So in this case, that first publication that we just looked at, and let's pull that up again because I know we're going very quickly. The first publication, apps, is actually returning all apps, and then along with some options, which we haven't seen what we're passing in here or how we're displaying this on the client side, but this subscription is powering that top charts page. This publication, I should say. We will subscribe to it eventually. This publication, single app, takes a function ID, and then it calls apps.find again, but now instead of passing empty curly braces, it's passing curly braces with an underscore ID, :ID. This means match this field, which happens to be the MongoDB ID field. By default, every document you insert into MongoDB automatically gets this property added to it. It's its unique ID in the database. And we're going to match that against the ID that's passed into this function. So unlike the first one, the second one is letting us subscribe to one individual app. So in fact, that's what's powering the page when we go from this link to this page. Right here, we only need this app. We'll see how suggested apps are handled in just a second. We only really need this one main app for this page. We don't need to subscribe to all of them. So to make it more efficient, we've created a separate subscription for that. And then finally, single app by app ID. For those of you that took the second module, you'll remember that what we actually have is a list of 5 related app IDs, which is different than up here we were talking about MongoDB identifiers. This is actually the app IDs we crawled from the App Store, and then we used them in the second module to be our array of recommended apps, basically, that we have 5 app IDs that are related to this app. So what's going on is as we're rendering each of these 5, we don't want to just show the app ID of these apps. We want to show the icon and the name like we do here. So we're going to use that app ID to look up and subscribe to just each one of these that we care about. And as you can see, similar to apps.find ID: ID, here it's apps.find app ID: the app ID that got passed in. So these two are very similar. One's filtering on MongoDB ID, one's filtering on or querying on app ID. Okay, so now we've created these 3 publications, but we still haven't done anything on the client side yet. So let's actually take a quick look at lib, and then we'll go over to the client side. So we'll get to routing in a second, but to just see on collections here, I probably should have gone over this a little bit earlier. We have apps.js. This is where we're defining this apps collection. So the reason we're defining it in the lib section is we're going to have server code that refers to this apps collection. We're also going to have client code that refers to this apps collection. We want it available to both sides, so it belongs in the lib folder. Now, the apps collection on the client side doesn't necessarily have all the information on the server side. It only has what we've published in publications.js. That's what it's going to be able to subscribe to. But let's take a look at this file. It's probably way more simple than you thought it was going to be. It's just apps equals, and this is where this is where we defined this global variable that we've used everywhere else. Apps equals new meteor.collection lowercase apps. So actually, if you opened up a Mongo database shell, in Mongo we're defining it as lowercase apps, but the convention for global variables in Meteor is to use uppercase. So in Meteor we're defining it as uppercase apps. Another Meteor convention, if you leave out many of you that know JavaScript, you usually define it as var apps. By doing it just apps equals, that makes it a global variable, which is what we want. We want to be able to access this from anywhere in the application. Oops, what did I do there? There we go. Okay, so we're going to come back to routing in just a minute here. It looks like I created a checkout in Git here. It's okay. We'll leave that open. Let's look at client. So just a quick overview of the subfolders in client. We've got layouts. So Meteor, since it's like a data-driven web application framework, everything is rendered off of templates. So you have a layout template, and in this case, we're just going to have one layout. We're going to call it I think we called it master layout. And the layout template is just, the basic container inside which all your content will go. Sometimes you have a navigation bar as part of your layout. In this case, we don't. We just have, for those of you that know Bootstrap, we just have a container and a row. Don't read too. I don't really want you to focus on the HTML today. That's why we provided the repository. The only important thing I want you to notice here is the curly brace, caret sign here, and then yield. This is basically saying everything around yield is the layout template, and then the content is going to go here. Yield is a special keyword that's used by our router to say this is where in the layout you're going to insert content. The next thing we have here is a style folder. We just have one file called main.css. Again, we're not here to really learn CSS today. That's why I provided this for you, but this is, and you don't have to follow them, just have one file named main CSS. In a more complex application, you might have many style files in here. That's kind of cool, style file, rhymes. But yeah, so this is where our styles are. So this is all the stuff you care about on the client side, the layout of the page, the styling of the page, and then the views are the individual templates that we're going to deal with, and any logic that goes with those client-side templates. You'll notice one of these files is a JavaScript file. And we're going to go look at these templates in just a second, but before we do that, also notice there's an index.html here. If anybody's done web design before, you'll be familiar with this file. What's interesting here is all we really have is a title inside the head tags, and then we have empty body tags. The reason these body tags are empty is because our templating engine is actually going to insert first our master layout and then any of our individual views inside of the master layout in these body tags behind the scenes for us automatically. So you would never generally put anything here in the index.html. The main reason we have it is because this is where you define a head tag, where you can put a title. It's also where you could put fav icons or touch icons or any of that stuff if you wanted to. So let's now look at one of our individual view templates. And then after we look at our first view template, we're going to go see how this all gets tied together with the router. So this is our top chart template. We'll see in a second that the top chart template is in fact what is powering this page here, the top charts page. And first we define a little nav bar, which this is really Bootstrap territory again, not Meteor specific. And you'll just notice this is where we define top charts, which is what we see over there. Actually, I want to show you the hot code push feature. Let's just delete top charts for a second and say test and then save the file. What we'll notice is by the time we get over here, this is automatically refreshed with the new code. So that's what I was saying. As you're developing, you don't have to stop and rebuild and constantly refresh everything. Meteor handles a lot of that for you, which is one of the really nice features. Anyways, so we have a nav bar, and then we have a UL, an unordered list in HTML, which is what's listing each of these apps. And this almost reads in pretty good English here. Each apps, call app preview, and I'm calling each little item in that list an app preview. And basically what's going on here is, so this syntax that we've seen a couple times now, curly brace, is called spacebars, and spacebars is Meteor's way of inserting and working with templates and data inside of an HTML document. So each hashtag each is a for each loop, and it's looping over this variable called apps that we don't know where that came from yet. And for each of those, presumably inside of this loop, this equals each of these apps as we iterate through. This is being passed to a template called app preview. How do we know that this is a template? This caret symbol here is the spacebar symbol for template. So when you see curly brace, caret, app preview this, that means there's a template somewhere called app preview, just like this one is called top chart. And in fact, that's defined in app preview.html. We're going to look at that in just a minute. But the first thing I want to come back to is that we have this variable called apps. We don't know where it came from yet. So one of the notions I want to introduce around templates is the notion that a template can have a data context or a piece of data attached to it that is the data that we want to use to dynamically render this template. And there's a number of ways in Meteor you can pass data to a template. We actually see one of the ways right here. We're actually passing this, which is a single app inside this each loop, over to app preview. So that's one way to set the data context of app preview in this case. But where did these apps come from? So now we're going to go over to router.js. Routing really is probably the most important part of a Meteor application in that it's what ties the server side to the client side. We have now defined some templates, and we've defined, excuse me, my nose is still a little stuffy. We've defined some templates on this side and some data basically on the server, but we have no way of knowing which template to serve when the user goes to the home page. So the router is what's going to define, what gets rendered where. So the first thing we're going to configure on the router, calling router.configure, we're going to set the layout template for the router equal to master layout. That was the layout that we defined right up here. And so again, that means that Meteor is going to insert any of our individual route templates inside of the master template. Excuse me. The next thing we see here is called a router.route. So this is where we're actually defining a route. And when you see the / like this is called the default route. So when you go to localhost :3000, and you could also just type a / if you wanted to, that's the default route. So we're defining basically the home route here, and we're giving it a name, top chart. Because this name, top chart, is also the name of our template, which is defined in topchart.html, Iron Router is smart enough to figure out that the template that we want for this is the top chart template. Let's say we name this something else, like homepage. We could still get it to use the right template by also defining the template property to equal top chart. Those are equivalent, and if we save the file here, we'll see that we refresh and nothing changes. It still works. But this is just another cool thing about Meteor. There's a lot of conventions that if you follow them, you get to write less lines of code. Okay, so the next thing here is the waitOn function. So waitOn is another property. Its value is a function. And it basically, when you go to this route, the homepage route, actually I should have changed that back, it's going to wait to render the template until this function returns. And what this function is returning is a call to meteor.subscribe. So this is the other magic half of the publications we looked at earlier. We can call meteor.publish apps, and then on this end, we're calling meteor.subscribe apps to that same publication. And also, let me jump back again. You'll remember that we took a JSON object called options. Here we're defining that. The options are sort, and sort also takes an object which we're sorting on two different fields. One is our average rating field, the number of stars, and -1 means we want to sort that in descending order, so the most stars down to the least stars. One of the things I noticed was since there are so many apps with the same number of stars, we needed a second way to sort them to get a uniquely sorted list. So the second factor I'm sorting on is app ID, which I don't actually think is a logical thing to sort on, but it did give us a unique list. And actually later in the project assignment, we're going to figure out a better way to sort this. But for now, we're sorting on average rating and app ID. And then we're setting a limit of 50 items, because otherwise we would get 3,500 back. And just the act of loading all those images into a Google Chrome browser is going to really slow our app down. So ideally, you would have some kind of pagination feature where as the user scrolled down, you'd load 10 more at a time. But that's beyond the scope of what we're going to do today. And the last all-important feature of the router.route object is this data property, which this is what's actually magically setting this is why we came here in the first place. Remember, to figure out what was setting apps here in each apps. And as we can see here, we're returning an object from the data function where there's a property named apps, and the value is apps.find, and we're passing in empty curly braces as we want to find everything. And we're using the same MongoDB sorting options that we used in the wait_on function. Now, you'd think, oh, it's already sorted on the back end with the subscription. Why do you need to do that? And it's really beyond the scope of this talk, but the way Meteor caches data when moving from page to page, I just wanted to ensure that every time we go to the front page, even if it's after hitting the back button, everything gets sorted correctly. So this just is a low-cost way, because when we call apps.find here, we're executing it on the client, and we've only subscribed to 50 apps, so we only have to sort the list of 50 again, not the list of 3,500 that this is going to be sorting on the back end in the publication. So this is basically just finding the apps that we just subscribed to in the wait_on function and binding them to this property apps. And this is going to allow us in the top charts.html file to access all those apps by calling each apps. We're then passing it to the app preview template. If we look at app preview, here we're actually going to access some of the properties on the object. So here the data context was set as apps, right, which is actually an array of apps. Over here, we passed an individual app in. So the data context here is one individual app. So by using curly brace, and ending with curly brace, we can reference the properties of one individual app. So here we're displaying the rank. Here we're calling the stars rating package. This is a template that was defined in that stars rating package that we looked at the very beginning of the talk. It takes as its parameters a rating, which we're setting equal to the average rating property of our app. It takes a CSS class for the star that we're passing in the class myStar, and it takes a size, which we're just using the small size. And then let's see what else. The only other thing I wanted to point out, Atom isn't doing a good job with its syntax highlighting, but if you notice here we have curly brace. So when you just have curly brace and you don't have, say, the caret, that means this is a template. It's either a property of the data context that you're referencing, or it could also be a function that you're calling. So in this case, path4 is actually a function that Iron Router gives us. And by saying path4 app page, this is actually going to generate an HTML link to our route called app page, which we haven't gone over yet. We'll see what that looks like in just a second. But let's go to the application. And these are the links that we're defining. Remember, app preview is the template for each item. So this is one instance of app preview. This is one instance of app preview. This is one instance of app preview that's being iterated through. So these links that are being generated, if we go and we inspect element, we can see the link that was generated was /app and then / what looks like some kind of ID, because it's a bunch of numbers and letters. And if we click that, we'll see indeed it takes us to localhost 3000 /app / it turns out this is the Mongo database ID of this particular app. So the lesson there basically is that path4 is looking up in our router, and I'll just show you where that is right now. We'll go over it for a second. Here's our app page route, so that's where you got the /app /ID here, and then it knows because because the data context of this is an app, it knows to take the ID of that app, and all that magic is happening by calling path4. Okay, so now we've seen, how top chart works. It's going to go through each app. We've seen how app preview works. So we've seen basically how we're building that list. Let's look a little bit more on app page now. We'll go back to the router. So we looked very quickly at this a couple seconds ago, but we're defining a route now instead of just the default slash. It's slash app and then slash, and this colon means it's the syntax for Iron Router for saying what's coming to the right is a variable name. So underscore ID. In our wait on function, we're subscribing to that single app publication that we made that takes a MongoDB ID, and we're passing in this .params.id. So this is how you reference the variable that's coming in through the route of your website. So again, if I click this, what's coming in is this string. So by calling this .params.id, I'd be accessing this string. I'd be passing it back to the single app publication right here, and then I'd be calling apps.find and matching, returning matching apps that equal that ID. So that's it. It's pretty simple. That's our wait on function here. And then our data function, we are just going to return apps.find1. So this is the same as apps.find, except it only ever returns one result, which is fine because we're passing in this .params.id again. There should only be one result, and that sets the data context of this template. Now up here we bound it to the name apps because we wanted to iterate through it. Here we just return the object because we've only got one object, one app, and we just want to access its properties directly. So the final thing we'll go look over is the app page template, which again, let's just go look at that again, right? This is the app page. And don't get intimidated here. There's a lot of HTML to make this look the way it does and to be able to scale on different size monitors. But let me just point out the important points. First thing to notice, we're actually defining two templates on this page. The first one is called suggested app. This is the template that's going to render for each of the up to 5 suggested apps for each individual app. So if we go back to the screen, each of these is an instance of recommended app. And the second template is the app page template. So this is the main template. Sometimes when you have a very small template like suggested app, you'll just put it in the same document. It doesn't really deserve its own document. It's only about 5 lines. So yeah, and just to go back to suggested app for a second, we'll notice we're inserting a image tag here, and the image is going to have the icon URL as its source. The icon URL, again, we crawled from the other app store, so this is going to allow us to use the image from the other app store without having to store the image ourselves. We're also, again, we want, if the user clicks on the image or the user clicks on the name of this app, we want to go for the path, we want the path for that app page, and that's what's allowing us to navigate between apps like this. The next thing we'll notice in the app page template, we have a backlink. This is the back button that we've been pressing to go back after we navigate into another page. We'll see how we actually do that backwards navigation in just a minute, but this is where it is in the HTML document. And then let's see, some of this stuff looks familiar from app page preview. We are still displaying the name of the app, the developer of the app. By the way, if any of these properties are confusing and you're wondering where these came from, go back to fixtures.js and notice that when we were parsing the raw app data out of the file, we set, like in the raw data we called it title, but in our application we called it name for name of the app. App ID got mapped directly to app ID, developer to developer. Before the intro data, we called it description here. So anyways, these are the properties that are available to us for one individual app. So when we're looking at the app page, that's where these properties came from. Here's the stars rating template. Again, that template was a third-party package. It's what's giving us this 5-star rating thing. We're passing in average rating, right? Which again, average rating. So you may notice that we didn't have to do curly brace average rating, curly brace, because we're already inside curly braces. So we're just setting that parameter equal to average rating. And let's see, this is the next interesting part here. Just like we had hashtag each in the other template, here we have hashtag if, which is an if block in the spacebar syntax. So when we're saying if recommended apps is the, up to 5 apps related to this app. Some apps don't have any recommended apps. So basically, if this is null, it's going to skip this whole block where we say customers also like, and we try to list stuff out. But if there is something in here, we're going to print customers also like, and then we're going to have another each loop. And for each recommended app, we're going to call that little template up top suggested app. And instead of just passing this to it, because remember, recommended apps is just an array of strings, and each string is an app ID, but we actually need to retrieve the entire app document from our MongoDB collection so that we can display the icon URL and we can display the name of each suggested app. So we're calling a function here called getSuggested_app, and we're passing this, which is the app ID. So in just a second here, we're going to see where this is defined and how we do that. And then down here after that if block, we have the description and we print the description. And that's basically it for the template. So the last thing we haven't explored yet in this application is the AppPage.js file. So these other pages, all these, in a typical application that's got a lot of functionality, each template will usually have a .html file and a .js. In this case, only AppPage has a need for it because we need to define this getSuggested_app function. And I strongly consider, at the end, I'm going to give you some links for Meteor, but one of the key concepts on the client side to get down is how templates work. We've already seen how templates can insert other templates, how templates can have data attached to them, either through a router, like we did with top chart and app page, or by when you call the template, passing it an object to set its data context. But the other thing is that templates can also have helper functions, which are functions that are available just inside that template, and you can also attach functions to events inside a template. So in fact, that backlink that we saw up top, by calling template dot the name of our template, which is app page dot events, we can pass an JSON object where the key is the event that we're trying to attach to, in this case a click event, and then the selector for the DOM element, they call it, which in this case the hashtag means ID backlink, and then you attach a function, which history.back is a function provided to us by Iron Router, which basically just says go to the last route that this browser was in. So this is our back button. And just to tie that together, if we go back to AppPage.html, here's the A link with ID equals backlink. So that's how we're referring to this with the hashtag backlink. This is a CSS selector. And we could have more of these. We could have, comma, click, something else, colon, function, blah, blah. Right, so we could have many events wired up in this single object. Similarly, up here, instead of calling template.appPage.events, we're calling template.appPage.helpers. And the helper function we're defining here, the key is the name of the helper function, and the value is the function you want to execute when this name is called. So we have this getSuggested_app function. It takes a string called app ID, and this is the first time we're calling meteor.subscribe outside of the router, but we're going to call meteor.subscribe. We're going to subscribe to our final subscription, single app by app ID, and we're going to pass it the app ID. So just to go back to that publication, single app by app ID was our final publication. It takes an app ID and then it searches our database for an app that has the given app ID. It's then up to us to actually call apps.findOne to find on the client side now that app ID, that app that matches our app ID, and we're going to return that object. So if we go back to our template where we call getSuggested_app, we're passing it the app ID. Basically, this is going to return our suggested app and pass it to the suggested app template. And that's just going to be rendered up here. I mean, it'll be inserted in here, but it'll be using this as a template. Okay, so that basically shows you how this is all working, how you're able to navigate, and you'll notice again that this ID is changing, so each of these apps appears to have its own unique URL, which is really cool. We've got our back button working. So where do we go from here? I mean, I know this has got to have been a lot of stuff to go over in one class, and again, the most important part of this class for learning is to really explore the code here. You know, you're going to clone a Git repository in a few minutes. You're going to be able to explore the code, play with it, change things, see how it works. I'm also going to, let me pull up my final few slides here where I'm going to link you to a few other resources. You'll also notice I have a lot of slides here that I didn't present because it was better to actually show it to you in the code editor, but I have more comments on a lot of the code in this PDF that you'll get when you clone the Git repository, so that could also be useful to look at. But here's the basic project setup instructions. You'll need Git if you don't have it already. You'll clone the Git repo at this URL here, which once we upload this video, I'll also link to this separately. You're then going to need to download Node.js. You're going to need to download MeteorJS. You're going to need to download a text editor or IDE of your choice. So I just did this demo in Atom text editor. It's free and open source, and a lot of people like it. I prefer WebStorm IDE, which if you have a student email address, you can use for free for a year, but otherwise it costs $100. And then there's also Sublime Text Editor, which I really feel like Atom is now the best text editor, so if you want to use that, it's up to you. All three are good options. There's a few other resources I wanted to link to. These first two I linked to specific sections of the Meteor documentation because these are sections that will be useful for the project assignment we're about to go over. The first one I linked to is the selectors, which is how you query MongoDB. The second one is the Mongo collection section, which is how you use the create, read, update, delete functions. They're named slightly different in Meteor. I think it's insert, update, remove is the three that you go over, but you may need some of this during the project assignment. If you want a little more total overview to Meteor, there's a great free tutorial on the Meteor site that gives you a good overview of all the different parts of Meteor, a little bit more in depth than we did today. And if you want to go even deeper, I highly suggest Discover Meteor, which is an ebook that also comes with a Git repository to follow. Each chapter corresponds to a commit in the Git repository, and they do a really good job of taking you through the entire process. So let's go over the project challenge here. Again, the most important thing is just to get familiar with how does this web application work. But if you breeze through that and you want a challenge, here's the challenge. Earlier we discussed that since many apps share the same average rating, we had to use the app ID as a secondary sorting mechanism. Earlier, this may have been hidden to you, but if you look in Fixtures.js, we did add a property to each app as we were loading it called number of recommendations. This property should be calculated by tallying the number of times an app appeared in another app's recommended apps list. We will add, we're going to add new logic to Fixtures.js in the main if block, which we're going to look at in a second so I can show you where it goes, right after we finish loading our initial data to calculate how many times each app was recommended by another app. This will provide a better secondary sorting mechanism, basically. First, we'll sort by the number of stars, and then the number of times another app recommended this app. So to achieve this, the first thing we're going to need to do is query the Meteor Apps collection to retrieve all apps in MongoDB and convert the collection cursor to an array. And I'll show you how to do this in a second, but basically Meteor's been doing this behind the scenes for us. When we call apps.find or some other query against the database, we're actually getting an enumerable back. We're just getting the cursor to go over the linked list. There's a special command we can call to convert it to an array. And this is going to make it easier to iterate over the collection ourselves. So that's the next thing we'll do. We'll iterate over the apps array. For each app, we're going to iterate through its recommended apps array, if any exists, which we're going to want to check for. And then using each app ID that we're iterating through, we can then update the appropriate MongoDB record by incrementing the number of recommendations property. And then finally, once we've done all that, I actually should have written two things here. First, we're going to display our new property in the app page template. So we would display in our app page for each individual app, this app was recommended n number of times by other apps. And then the other thing we're going to want to do is update our sorting. Remember our router, we sorted by average rating and then app ID. We're going to want to sort by average rating and then number of recommendations. Now, one little tip I wanted to give you, and we're going to just explore a little bit of how you can go about developing this. Our code's only going to run once. Is only going to run once since it's wrapped in an if block that's checking for an empty app collection. So let's close PowerPoint at this point. Go back to fixtures. Remember, fixtures.js is wrapped in this if statement, and it's only going to run if the apps collection is under 1. If it's over 1, then it won't run again. So this is good because we don't want to load our data every single time we start the application, and we don't want to tally the number of times an app is recommended by other apps every time we run the application. So your code's going to go here inside this if block. Right after we've done our for loop to load all the data before the end of this function, the code should go right here. But the downside to this is once we've run it once, this code's never going to run again. So you need to know how to reset your database. So right here is where we started the Meteor server. To end running Meteor, you could close the terminal. You could also do Control-C. Right now we've got our prompt back. If you type Meteor reset, that means project reset. That's actually reset our database. And the next time we run Meteor, it'll run that code block again because now our database is empty. Okay, so the second thing I wanted to show you is unless you get WebStorm, it's going to be hard for you to set breakpoints on the back end. There is a plugin for Atom that gives you some debugging, but WebStorm is the better debugger. This is a pretty short amount of code, so you shouldn't really need a debugger. There's another way we can develop pretty easily. If we open another terminal here, you got Meteor running over here. We can type, we can go to the same directory first, documents, Meteor dev in my case, App Store, and then we can type the command Meteor shell. And this is going to open up a shell on the Meteor server side that lets us interact with the running server. So just to illustrate that, if I type console.log hello, we'll see that our Meteor server over here on the left actually executed that command and printed hello. Similarly, we can do multi-line statements. For example, if I do for var I equals 0, remember we're going to be doing some iteration in this project assignment. I is less than 10, I plus plus. As long as I don't type a colon at the end of this line, I can return and go to the next line and say console.log, and this is how, again, console.log is how you print to the screen over there, console.log I, and then let's close with a, oh, I have a syntax error. It's funny, it actually printed that even though I had no curly braces. Interesting. Okay. you could see what I was trying to do here. I was setting up a for loop. I thought I needed a curly brace here, but I guess since it was a single liner, curly braces are optional. But you could see it printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The last thing I wanted to show you, I mentioned that when we do apps.find, let's just try that right now. Apps.find. This isn't actually, it's hard. Let's maximize this for a second. This is returning some Mongo information basically. So apps.find, this is actually called a cursor. So this is a cursor needed to iterate over the collection, but it's not actually the collection itself. So instead of apps.find is fine in Meteor because Meteor is going to call the cursor behind the scenes. But let's say we just wanted to get an array of all our apps. Apps.find like we just did, and then additionally .fetch. .fetch forces the iteration to happen and gives us an array back. So now we see each of our apps. They've each got the underscore ID, which is their MongoDB ID. They've got a name. They've got an app ID. They've got a developer, description, average rating, icon URL. This one doesn't have any recommended apps, and then number of recommendations. This is what we're going to be calculating. Each of these is starting at 0. So basically, this is the number we're going to be incrementing. And I think that should be enough information, even though you may have to watch this video a couple times to get everything. I'll be interested to see how this project is going for people. I will be on our class Slack answering questions. And yeah, I look forward to seeing if people get excited about Meteor. I know I threw a lot at you here. Maybe some of this is my own learning style, whereby there's two ways you can approach things. One is to have all the documentation up front and study it meticulously. The other is to just kind of be thrown into a project like this. You're given some code that works, you're given the structure of the application, and so you can kind of reverse engineer it, see how everything's working together, and then I'm happy to answer questions and point people in the right direction towards where you would work to get more specific information. And again, right here on this Meteor resources section, the documentation is a great place to get a better feel for what's going on, and then at least do this Meteor tutorial if you're really struggling, because they're going to take you from the beginning in a slower way. I wanted to get this video into about a 45. I think I'm a little above my 45-minute format here, but I wanted to give you guys enough details that you'd be able to be successful in navigating this application. So thanks for viewing this class, and I hope you have fun exploring Meteor. Thanks.